Hi everyone, good evening.
Good evening, sir.
Yeah. Good evening everyone. We had to discuss today project, isn't? I hope I have told that on Tuesday we are going to discuss. Okay, no worry at all. Let's do one thing. We can discuss this project on Thursday. But on Thursday, I'm just going to see the complete project. If any suggestion will be given, I will give you at that time. Otherwise, I'm expecting that all of you would have completed this project. Okay. Yeah, everyone. Okay. Um, I hope all of you have come. Now, guys, I just wanted to ask you, have you been provided the syllabus of your course? Pranav, Sanket, Sumit?
सर सिलेबस तो नहीं मिला था बट जो वहाँ साइट पे अवेलेबल था बस वही डाउनलोड किया
हाँ, वही मतलब वो आपके पास है ना?
हाँ सर
एक मिनट रुकना होगा। हाँ दोस्त, एक मिनट रुक सर। All right, everyone, let me show you. See, this is your syllabus. Okay, this is your syllabus. See, we have started with this model 2. To be very frank and honest, I had discussed them, not the, there was something we had discussed, but there was something that we have not discussed. Yeah, but I have done all of this. I've done all of this, but still, you just do one thing. You just go and check. I don't have any, problem. I'll just share it in the group. I have shared in this chat. You can just go with this link and see the syllabus. But why I'm telling you, just go and check each and every topic that is mentioned in the module. And because in the next week, probably I'm going to complete this syllabus. Okay. So if you think that just make a list of it. Make a list of it. And, on Friday, I'll just tell you that these are the some topic that needs to be covered. Or probably, what I'll just try to complete it by the next Friday. So that 2 days we can keep for the doubt clearing of the overall. Getting my point, everyone? Yeah. And see, I'll not take a speed to cover it. If that will not be covered on Friday, we'll take another 2 days. No issue at all. Yeah. But the thing is that I just want to keep 2 days for doubt clearing session. If you will have overall doubt, you can discuss us. Yeah. Second thing is that, so I've just shared you the syllabus. You just make a list. You just make tick mark. Whatever has been covered and whatever has not been covered. Why I'm telling you? Because I will declare, but until unless you are not also sure that each and everything has been covered, somewhere not make me satisfied. Yeah. So that's why I always become transparent and I have shared this syllabus to you all. Just go with it and just make a list. Yeah. And no worry, I'll just cover each and everything in this week. And on Monday, I will tell you that these are the topic left. If you say, no, sir, still, if you see, you can directly tell me, sir, these topics are left. Other than whatever you are saying. I don't mind. Either I would have covered it or I would not have covered it. If I would not have covered it, I'll accept it. If I will have covered it, then I'll tell you that, guys, just refer it. I had covered here. Getting my point, everyone? Sumit, Dipali, Sanket, Vigya, whoever is there, Kushbu, Abhi. Yeah.
Yes.
Okay. And to be very frank and honest, guys, if you have seen that, although I had avoided, but still I took leave on Monday. Usually I took leave on Monday because to be very frank and honest, I'm not well since 1.5 months. So I just have to go to my physiotherapist for the physiotherapy. Usually I was going into the morning, and Monday I was not able to avoid. So, that's why even I require 2 weeks. But because of this, now my appointment is on Monday and Wednesday for both of this week, even for the coming 4 weeks, because this will be the process for the coming 6 months. So Monday and Wednesday I will not be available. So what I have decided then, let's give me your 2 Sunday. Please give me your 2 Sunday only. I know that you may have your personal commitment also. You may have some other work also, but give me only your 2 Sunday. So this week and the next week we'll have class on Sunday also, so that your syllabus could be covered on time. Yeah, without compromising with the time. And I hope you will understand my problem. See, otherwise, what I can extend this, but what I think that I should wind up now for coming 2 weeks, and that's why I'm going to take class on Sunday also. So this Sunday and the next Sunday also there will be a class, and the class will be Tuesday, Thursday, Friday, Saturday, Sunday. And guys, it might be that you have never, felt it that just because of my voice and all, because whenever I start delivering, I forget each and everything. That whether I have pain or not, I just forget each and everything. But I cannot avoid to visit to my physiotherapist, so I'll have to go there. And that's why for only 2 weeks, I just want the favor from your side. Because after the completion, if you're not satisfied with the content, with the delivery, then it's somewhere it's my fault. It's somewhere I'm the loser, and I don't want this. Okay, so guys, please respond in the chat. Will you be available on Sunday or not? And to be very frank, I just want to see yes for these 2 Sunday only. So just response everyone in the chat. Thanks, Pranav. Yeah, thanks everyone. Really, really thank you. Really thank you, everyone. Yeah. Okay, so I really appreciate. And guys, now, please, on Saturday and Sunday, means Friday, Saturday, Sunday, the timing will be 8 to 10. Yeah.
Sorry, sir.
On Saturday, Sunday, means Friday, Saturday, Sunday. Right now, you're meeting at 7:15, no?
Yes, sir.
So from Friday, Saturday, Sunday, it will be 8 to 10. If you guys don't have any issue, otherwise we can meet at 7:30. Whatever suits you, please tell me. It will not according to me. It will be according to you guys.
Excuse me, sir.
Yeah.
Sir, is it possible to take a class in the morning?
On Friday, Saturday, Sunday.
Yeah.
See, on Friday I can do, but on Saturday, Sunday I will not be available.
Sir, actually, we should, fix a time जब सब लोग available हो in the morning and it suits you also.
Yes, you can take this call, because I tell you, On Saturday, hold on. Yeah, on Saturday and Sunday, I have already the batches in 8 to 11. I have already batches. Yeah.
Then, sir, it'll be okay if we go with the same time only.
Yeah, because yes, if right now we can decide that we can meet in the morning of 6 to 8, but only 50% will be available.
Yes, sir.
50% will not be ready to leave their bed. Okay, yes.
Yes,
Yeah.
sir.
So we'll be meeting at 8, or if you guys say, then we can meet at 7:30.
Sir, I guess 7:20 is okay. Because
7:30. Okay, let's do it on 7:30.
8 is
Yeah.
quite late, I guess.
No issue. So we'll be meeting at 7:30 on Friday, Saturday, Sunday. It will be somewhere the same schedule, isn't? So yeah, let's start now. I know that there are some, reschedule in the timing is happening, but to be very frank, guys, it was just because of my health. Otherwise, your IIT does not do it. We are committed to each and everything what we have committed, but right now we don't have the other options, and that's why we are trying to manage the things. And I'm really sorry for it, because we are rescheduling the time from 7:15 to 7:30, but I just want to give the little bit more time on this. And one more thing is, again, please make a note. On Thursday we are going to discuss the project. Although I really appreciate you people that you were showing more sincerity in comparison to the ML people. But still, I just want to see the complete project on Thursday, where you would have done the data cleansing, you would have done Khushbu on Friday. Okay, no issue. Let's do it. Let's on Friday we'll be discussing the project. Fine.
Excuse me, sir.
Yes.
Sir, could you confirm once again on what days the class will be held?
Sorry?
Can you confirm again on what days the class will be held?
This project class you're talking, or the last class?
No, regular classes.
Okay, the regular
Like
class
on
will
what
be
days we'll have our class?
Thursday.
Tuesday,
Tuesday.
Thursday, Friday, Saturday, Sunday.
Yes, except Monday and Wednesday.
Okay, sir.
Yeah.
Yeah.
Okay. Now, and in this Friday, we are going to discuss the complete project. In this Friday, please make a note. All right. Okay. Now let's start, guys. And if you remember, we had discussed the convolution neural network. And guys, again, I'm knocking you guys. Please just go through with the syllabus. And on Monday, I will be telling you that what are the topic left to cover. And if you think that no, sir, in addition to this, these are some other topic also that needs to be covered. Please knock me at that time. Yeah. Okay. So, if you remember, on the convolution neural network, we had seen each and everything. What is the pooling? What is the ReLU? What is the convolution? How we work on this. But during the time of the implementation, if you remember, guys, we took MNIST data, isn't? This is the handwritten digit images that are the inbuilt data set of the Keras. And I told you that whenever you have to work with the convolution neural network, this is best suited with the images. Do you remember? And one more thing I tell you, that whenever we work with the images, whenever we work with the convolution neural network, that convolution neural network, we have two options. One, either we can use the predefined architecture. Yeah. Predefined, or I can say that pre-trained model. And this pre-trained model are already trained on the 1,000 classes. Yeah, these 1,000 classes are carried in a data. That data is called as ImageNet dataset. So basically, this ImageNet dataset was having data which were containing 1,000 different classes. So every, for example, suppose that I would have given this data to you people. Obviously, you'll be applying the convolution neural network, and I'm pretty sure that if there are 4 people who had worked on the same data, but they will have different architecture of your convolution neural network model. Isn't, guys? In the same way, what has happened? Yes, 1 second, please. So I just show you one thing. Yes, pre-trained CNN models, or let me do one thing. I'll just tell it ImageNet models. Yeah, ImageNet models. So you see, there are VGG11, VGG13, VGG16. They are what? They are the pre-trained models. Okay, and if I show you what are the different pre-trained models, so these are the different pre-trained models, just like ResNet 18, ResNet 34, ResNet 50, ResNet 101. So these are what? These are the different pre-trained models, and if I talk about the ImageNet data, you see, the data is containing how many classes? 1,000 object class. 1,000 object class. I'm not telling that this is the size of the data. It is containing 1,000 different classes. Yeah, and the size you can see. So basically, one competition was organized, and everybody has tried with their own architecture, and this architecture was called as named this models. So you have 2 options. One option is that you can use your own CNN architecture, or you can use this pre-trained models. So how do we work on our own CNN architecture? I have shown you, isn't everyone? But we can use the pre-trained models also, just like ResNet 101, ResNet 151, VGG60, DenseNet. So these are the different on which we can work. Second thing, guys, as I told you, that this CNN is best suited for the image data. So fortunately, unfortunately, we have worked on the MNIST data, but this is the inbuilt data set. But suppose if you have to work on if you have to read an image, if you have to load an image, then how you will work with the images, how you will read that image into your Python. We have not worked on it, isn't everyone? Yeah. So today, first of all, what we will see how to read an image, and second thing, how to use any pre-trained models. Okay. Yeah. Give me 1 second. Friends, I have shared two files. One is mobilenet.ipynb, another is resnet applelips.ipynb. Okay, so we'll show you how we work on the pre-trained model, and before that, I'll tell you how to read an image. Okay, everyone. So you please confirm. Did you get that file? All right. So what I'll do now. Okay, I'll just open this Google Colab. I hope my screen because I stopped sharing. So I'm just opening this
Yes.
Google. Yeah. So I'm just opening this Google Colab. Okay. And I'm uploading the first file that is named as mobilenet.ipynb. Okay. And let me connect this. So, the first thing that whenever you work with the Google Colab, and if you have to read the data, then where you upload that data? Can anyone tell me? If you have to read a data into Google Colab, then where you upload this data? Where you upload this?
So on the drive.
In the drive. Okay. So I'm just mounting my drive. Next. So in the same way, can I say that if I have to work with images, that image should also be lying in my drive? Okay. So what I did, I just download one image. Say that that image is a cat image. Let's talk about any cat image. Say that this one I'm downloading. Okay. Okay, no issue. I'll just save it. Yeah. And this download, I'm just saving it as, or okay. Yeah. We're okay. I've just downloaded it. Now what I'll do, I'll just upload it into my Google Colab. Okay. My drive is already mounted. I just went here. Say that in this data set, I'm just uploading it. I just clicked on the upload. I went here. Where's my file? Hmm? Let me do one thing. I'll just upload any of the image here. Uh, Although it was for the mood recognition, but let me check. Let me do here. I'll just upload this image. Okay. Yeah. So if I go into this data set, this is the happy women.jpg. Yeah. In the same way, you see, in this data, I had doc24.jpg. If you see in this data, we have this 24 doc24.jpg. Is there? No. We have doc1.jpg. Yeah. So what I'll do, I'll just copy the image that I have uploaded right now, and that is what it's a happy women. Although I tell you the image that I had downloaded, this happy women, it was just to show while analyzing your images using the YOLO model, how can we predict that whether the person is happy or the sad, something like that. But let me copy this path. I'll just paste here. Okay, let me import this TensorFlow, NumPy. I've just got this path, and that path is inside the variable file name. Now, we have 4 methods through which we can read an image. One is what? That is the ipython.display. Yeah, through this ipython.display, we'll import this image. Yeah, either here we can give the path of this image like this, or we can give the variable, and then we'll decide. We'll tell the size of the frame, the size of the window in which the image will be displayed. So that is width equals to 224, height equals to 224. When I'm running this, you see, so this is the one way through which you can read an image. The another way through which you can read an image, that is through Keras. So again, you have to import the same library image, but right now this image library you'll be getting from the module, that is tensorflow.keras.preprocessing. Okay, and through this you are going to call a function that is load_img. So image.load_img, and again you see this file name is what? This is the variable that is keeping the path of the image. This is the variable that is keeping the path of the image. Okay, and the window size is 224 by 224. So we have just loaded this image, and you know that this image we have loaded into img1. Now, through imshow function of the matplotlib, we are displaying this img1. You see? So this is the second option through which you can read an image. The next option is what? This is the CV2. So whenever you'll be importing CV2, before that, you will have to make sure that you should have installed the OpenCV. Okay, so you would have installed the OpenCV. After installation of it, you will need to import the CV2. Since I have already installed this OpenCV, so I'm not going to install it again. But yes, whenever you have to use this CV2, before that, first of all, you need to install this OpenCV. Okay. Then the CV2, you need to call a function that is imread. That is imread, and So cv2.imread, you are giving the file name. And what is this file name? It is telling you the path of the image. And you're saving it into what variable? You're saving it into img. Okay? Into this img, you're saving this, you're reading this image. Then again, through the imshow function of the matplotlib, you're going to show it. Can you see? Did you find any difference, guys? Did you find any difference? Can you please tell me, did you find any difference?
Brightness color is different.
Yes,
Like it
Kushbu.
was.
Basically, it is blue, green, red. Actually, the channel that we have, the channel that we use to read an image, we use RGB channel, red, green, blue. But whenever you'll be using CV2 library, it will be reading in the channel of the BGR. So what we'll have to do, if you want to them into a natural image, then you'll have to convert them into from BGR to RGB. And we'll show you, not to worry. I hope you got my point, everyone. Next. The another library is Pillow. The another library is Pillow. So again, if you have to use this Pillow, you need to install this pip install Pillow. Yeah. And then from PIL, you are going to import the image. Okay. From this image library, you are calling the function open, and this image.open will be taking the reference of the URL. Yeah. So either you can directly provide the URL, or you can save that URL into a variable, and you are passing that variable here as an argument. So you're opening this image into what? You're opening this into IM. And then if you want to resize the window, you can call this resize function. Otherwise, it is not necessary. You can use it or you cannot use it. Yeah. Then again, through this imshow function of matplotlib, you are showing it. So first thing we came to know that what, whichever model you'll be using, whichever library you are using, except your OpenCV, all of them are reading them into a RGB channel. Only your OpenCV is reading them into a BGR channel, blue, green, red. Okay, now. Here, so far what we have seen, we have just used the different library to read the image. Now guys, another thing is what? As I told you that we'll have the pre-trained model. Okay, so here just like you see, we have this mobile net. So mobile net is what? It is also a pre-trained model. Okay, now we are building this model from where? From tf.keras.application.mobilenet.mobilenet. Now, see, whenever we have to work with the prediction or we have to work with the supervised learning, whether we are using the deep learning or any other ML algorithm, we first build the model where we define the architecture and all. We train the model, test the model, and prediction. Even if I talk about the deep learning, if you remember what we have done so far, whatever model we were using, in case of CNN, first of all, we were using the convolution. Then we were using the ReLU, then we were using the pooling. Okay. And then after, we were using the fully connected layer, that was the artificial neural network. Fully connected layer. So whenever we are building the model, first of all, we are specifying it. We specify the model where we were specifying the architecture, and then we're compiling the model, and then we were training the model. So in case of pre-trained model, we don't need to specify it. We don't need to specify it. We'll be directly training the model. Yeah, we'll be training the model on our data that has already been trained on any, some predefined classes. And that's why you see here, again, what we are doing. First of all, we are processing the image that we have already processed, but still, just to be in the continuity, we'll be using it. Yeah, so we have just loaded the image and we are showing it. Okay. Now, see, first of all, we are converting them into a image. Into array. We are converting them into the array, and then you see here, we are expanding the dimension. We are expanding the dimension. Why? Because see, if I see the shape of the resize image, it is what? 224 by 224 by 3. When I'm talking about this final image, right now, can you see here? What is its dimension? 1, 224 by 224 by 3. Why? Because guys, this mobile net model takes 4 dimension. This mobile net model takes 4 dimension, and whenever an image will be represented, it will be represented into 3 dimension. Yeah, it will be represented into 3 dimension. So just to fulfill its requirement, we have expanded its dimension from 3 to 4. Yeah. Now we are going to pre-process it. And you see, we are going to pre-process this input image through what? Mobile net. Yeah. In another way, I can say that we are going to train this model on your image data. You see, we have not specified any model. We have not specified any architecture of it. We are already using the predefined architecture of this mobile net model. Directly, we are training it on what? On your data. And then after, you see, we are doing prediction of this on our final image. Just like, we are training the model and then we are testing on it through predict function. So we are predicting it by calling the predict function. Yeah. If you see it, then it is showing the array. And obviously, you will not be able to interpret this outcome. So what we will do now, we'll just use the ImageNet_utils. Why we are going to use it? Because it will just decode this array. Whatever prediction you got, it is going to decode it by calling the decode_prediction. And we just apply this on the predictions, which is carrying the result in the array form. Now, if you see this result, then actually, what it is showing you? It is showing about the coat, that this is the trench coat or the, wig, lab coat, yeah, sweatshirt. So actually, it is trying to predict about the cloth that a woman has wear. Yeah, because it means the model was not trained to classify whether the person is happy or not. Getting my point? And that is why this mobile net is not suited for if you're trying to classify whether the woman is happy or sad. Okay, but suppose I just read this data Yeah, give me 1 second. I'm just copying this function, of copying the path of the dog image, and I'm just providing it inside this. Okay. Now, if I run it, if I show you, so this is my image. Yeah, this is the image of a dog. Now, again, the same process we have applied. We processed it, isn't? Now, we are doing prediction on the data. Yeah, and again, we are going to decode it. You see? So when you're now, it is saying that whatever image you have set, either it is golden retriever, and it is saying that it is classifying this result as a golden retriever with how much accuracy? 99.65. It is classifying this dog with, what is this breed? I don't know, with only 0.0014 accuracy. Labrador retriever with this much of accuracy. You see, according to the accuracy of it, this model has classified this particular dog as a golden retriever. Yeah, this has classified it as golden retriever. So why right now it is giving us so much accurate prediction, but in case of that happy women, it was talking about the cloth, not the face of the image. Because you see, when you were looking at this image, see, particularly the entire image is focused towards the cloth. Is the major proportion we talk about, that is over the cloth, while here that was according to the dog. But another thing I tell you, basically, if you will be seeing, then might be that you know the mobile net would not have been trained on classifying the women or the men. Yeah, might have the data that it took there was not the class for it, the men and women. It was for the clothes. Yeah. So that might be a drawback of a pre-trained model. This is just like, suppose the kid has seen only two objects, say apple and tomato. Now, whatever fruit or the vegetable you'll be show him, it will just try to correlate it with whether it is apple or the tomato. Whatever object you will show him. If you know only the apple and tomato, then it will just try to roam around it only. In the same way, whatever classes on which your pre-trained model was trained, it will try to classify them on the basis of those classes only. And that's why, although you have provided the image of a woman, but it was doing classification of the clothes, that whether it's a sweatshirt or the jacket or the coat and all. Yeah. Now what I'll do, I'll just use the same data, same image of what? Same image of the women. Let me check. But now I'm just using the MobileNet V2, the another version of the MobileNet. Okay. Now I'll just again do prediction of it, just to process it. Okay. And I'll just do decode it. Now when I'm decoding it, and printing the result, You see? Hold on. Let me do one thing. So this is the path of the happy women. So I'm just providing the image of the happy women now. Hold on. Okay. String and float where? Okay, no issue. I'll just again run it. Put it right. I'll have to see, guys, why it is giving the error. But I don't want to waste time. I'll just go into it. Yeah, and tell you. But at that time, I just wanted to see what will be the prediction of it. So friends, I'll just share these two images and you please work on it and see what is happening. So guys, might be some of you will be into the academic. So in the research point of view, sometimes we use the concept of this pre-trained model. And if you see that your accuracy is not matching, the result is not matching with your desired accuracy, then that might be happen that the model that you're trying here, that model has not been trained on this class. The pre-trained model that you are using, that model might not have been trained on this class, and that's why you are facing this error. Okay, so in that case, what you can do, you can try with some other pre-trained model. Okay, so let's do one thing. So far, what we have done, we have just seen how to read an image. Yeah, but what exactly happens sometime that if you want to train your model, if you want to do classification, then your model should be trained on multiple images. Okay, your model should be trained on the multiple images. But right now, what we have done, we just trained the model on the single image. So whenever you have multiple images, then first of all, we should know how to read the multiple image. So I'll just show you first that how to read the multiple images. And for that, I just show you one thing. Let me show you the drive. You see, in this drive, there's an Apple _ data folder. Okay. In this Apple _ data folder, we have two folders. Can you see? One is apple underscore black underscore rot, which is the disease that found in the apple leaves. Yeah. So these are the images that we have. It is having these are the leaves which has the black rot disease. Another is what? We have another folder, which is the apple underscore healthy. And these are the images which are the image of healthy leaves. They don't have the black rot disease. Okay. Now, what we guys are going to do, we are going to read these all images. We all are going to read these all images. And friends, how the model will be working, we'll see in the next class, because it will take some time. Or let's do. So let me upload the another notebook. I think I have shared you this one, no? Okay. So let me connect this. Okay. Now you see, we just made the current working directory. We just made the current working directory to what? To my folder. You see, in this apple underscore data, what is there? Those two folders. One is what? Apple underscore black rot and apple underscore healthy. Okay. Now, friends, these all are the model building libraries. So we'll discuss it later on. Let me show you only this globe. This CV2, if you remember, this CV2 is for what? To reading the image. OpenCV. And this globe. This globe is actually used to go to the folder and read all the images. This globe will be used. Yeah. So we'll just run this, import this, all the libraries. But here, as we are going to see only how to read the image. So let me show you. Now, you see. This Apple underscore data. In this My Drive, this Apple underscore data folder. And in this Apple underscore data folder, we have the black rot and the Apple underscore healthy. And you see, in this Apple underscore black underscore rot, we have lot of images. Can you see? And in this Apple underscore healthy also, we will have the multiple images. So just to read the multiple images, what we have done, we are first of all defining the image size. Let's take a variable epoch and the batch size, although that is not needed here, but still we can do it. This is the path of the disease leaf, and this is the path of the healthy leaf. Now you see what we are doing here. We are using the two variable. One is what? Disease underscore files, and another is healthy underscore file. And what we have seen, see, this glob is used to read the images inside a folder. And I told you that it is used to read for the multiple images. So up to here, what we have done, we have provided the image of the disease image. That means the black rot images. Okay. After that, you see, we just concatenated this slash star. What is the meaning of that? This globe is telling, just go till here, and after that, you just use the path of all the images. First, you got say that first.jpg, so it will become, after that, it will concatenate this one, then after 1.jpg, then 2.jpg, then 3.jpg. So this globe is going to concatenate the path of each single image. Each single image means it is going to read all the multiple images by concatenating the file name .jpg of each image. And that is going to be done for the disease and the healthy both.
Sir, can you please repeat about concatenation once again?
Okay, I tell you. Suppose there are the multiple images. Let's say that we have 1.jpg, 2.jpg, 3.jpg, 4.jpg, and 5.jpg, for example. Okay. And where they are situated in the content. Inside that content, there is a drive. Inside the drive, there is a my drive. Inside that, we have the Apple underscore data. Inside that, we have the Apple underscore BlackRock. And then after, we will have path for 1.jpg, for 2.jpg and all. So through this, what you are getting? Through this, you are getting up to this one, isn't? And after that, you're concatenating what? Slash. And after slash, you're saying star. Star means you will take all the path. You'll take all the images here. But you know, that images will be coming one by one. So you'll have to take loop. That is another part. But say, after that, first it will take 1.jpg. Then it will take 2.jpg. Then it will take 3.jpg. Then it will take 4.jpg. So means directly you cannot read all the images with a single path. So that's why this globe has used. And what it will do, it will enable you to read all the images one by one that are residing in the same folder. I hope you understand now.
Yes, sir.
Okay. Now, see. For that purpose, we have used this code. We have used this code. Please try to understand. So here you see, suppose we have 5 images only. Okay, we have only 5 images. For instance, say we have only 5 images. So now, friends, so you see, we have taken two lists, disease underscore label and disease underscore images. See, in the same way we have done for healthy underscore labels and healthy underscore image. Let's do one thing. Right now we'll be talking about the disease. So we have 2 lists. One is what? One is disease underscore label. Another is disease underscore images. So we have two empty lists. Now, can anyone tell me what this disease underscore files? What is disease underscore files? So you know that this is keeping the path of all the images through globe. Through globe, it is keeping the path of each images. You see? There. Disease underscore files. Yeah. In the same way, healthy underscore files keep the image of all the healthy leaves. Next. So, since we have multiple images, so we are going to read them one by one. We are going to read them one by one, and that's why we have applied loop. Okay. If you remember, through CV2, we are using imRead function. Okay. We are using the imRead function. Now, this loop will be running up to when total number of images. And I told you that consider we have total 5 images. So this loop will be running for 5. Let's say that I is equals to 1. So it will be reading what? The first image. And then you see what we have done. We are calling the CVT color function, and that will just convert this image, whatever you have read, into RGB channel from BGR. Because this is the problem with the CV2, that it always read the image in the BGR format. And you're resizing them into a 224 by 224. And then you just read this image, say that the image was what? That was 1.jpg. So you just read this 1.jpg into what? Into this list, that is disease underscore images. So we have right now 1.jpg into this disease underscore images. Okay. And what you did now, in the disease underscore labels, you just appended what? You just appended the black rot. Apple underscore black underscore rot. Okay. So now what is happening? In our disease underscore labels, we have one label, apple underscore black underscore rot. In the disease underscore images, we have one image, that is 1.jpg. Okay. Now what will happen? Again, the loop will run. The I will become 2. So what will happen? It is going to read the second image. Again, this second image you will have read, and you will be converting them into RGB channel. And then you're going to append this image into what? Into this disease underscore image library list. And then in this disease underscore labels list, you're going to append another label, that is what? Apple underscore black underscore rot. Again, what will happen? The loop value will increase and it will become 3. So you will just read the third image, you will convert them into the RGB, and then you will just append that image into what? Disease underscore image list. And pointing to the I equals to 3, you're going to append the same label, that is apple underscore black underscore rot here. In this way, it is going to be repeated until and unless you have read all the images. Okay, so the way you have fetched the images for the disease data, in the same way you're going to fetch the images for the healthy leaves. Means the same loop will be repeated for the healthy images also. Same processing will be done for the healthy images also. Okay, so you see here.
Excuse me, sir.
Yeah.
Sir, I just want to know why we are resizing it to 224 to 224.
It's up to you. It's up to you, because the standard size that we used to read, that is 224 by 224. You can have your own size also.
But so the pixel size that ranges, that is from 20 to 255. If I'm not wrong.
See,
image size, the pixel size, because अगर हम
No. That is the color coding. That is 0 to 255.
So sir, अगर हम BGR भी ले रहे हैं, that is ग्रे वाला, और RGB ले रहे
BGR का
हैं,
मतलब क्या हुआ?
so black, that is your
No. Blue,
okay.
green, red. Blue, green, red channel. You have
Blue,
taken, yes, blue,
हाँ.
green, red channel. RGB का मतलब क्या हुआ? The combination will be of RGB channel.
Okay. तो सर रेंज तो कलर की 0 to 255 ही होगी ना, कि नहीं?
तो मैं यहाँ पर उसकी बात नहीं कर रहा हूँ, मैं आपको जो विंडो साइज है, इमेज साइज, ठीक है, उसको किस में दे, ठीक है?
Okay, sir, I got it.
Okay. Now you see. So can you see here that since the loop that we have read, the loop we have taken here, same loop we'll be using for reading, fetching the healthy files. The way we have fetched the healthy disease images, in the same way we're going to fetch the healthy images. Okay, right now it is working. You see, it is at this line.
Sir, the CVT color function is of CV2 library or any other library?
It's a function of the CV2 library.
Sir, so why in CV2 it is in BGR format already?
It's a default that it read, and just by if you want to convert it into RGB, then you have to call the CVT color. When you'll be calling the SIM read function, then default it will read into a BGR channel.
So sir,
But if you,
yeah. Sir, is there any need for the BGR format?
see, if you don't want, no, there's no read. But what we have done here, we have used this CV2 library to read an image. If you don't want to do this, you can use the Keras you can use the image library of the Keras, or you can use the image library of the Pillow just to read the image. It's up to you.
Okay, sir.
Yeah, here we have used CV2.
Okay.
You see, it has reached here. So friends, what we will do, we'll just see how to read the multiple images, and you have to try by your own. I'll just share you the drive link of the images that I have used here. You can download from there, or you can download the multiple images from yourself, by yourself, and you can try this. Okay. And tomorrow means on Thursday. Means tomorrow there will be no class, On Thursday, what we will do, we'll just see the different pre-trained models that we can use to classify whether the leaf that we have entered, it's a black rot or the health image. Okay. And on Friday, we are going to discuss the project. So you know why it is taking so much time? Because we have multiple images. We have a lot of images. And if I check this runtime, we are already using TP. Yeah, so it has read, isn't? Now, let's show it. So for showing it, we are just defining a function, and you see what kind of function we're defining. We're saying that the total number of rows will be 4 and the total number of columns will be 6. So the table will become 24. 4 by 6, 24 data. So we are going to display 24 images where each size will be having 10,6. Yeah. So we are just going to show them in the subplots, and you can explore it by going to the help. And then we are just displaying it. Okay. We're just going to display it. Let me first display. Then if you have to work on it, discuss, we can discuss it. You see? So it has just displayed your, and you see total how many rows you have used, 4, and how many columns, 6. In the same way, we have the healthy images. And friends, do one thing. Even you see, I have just commented one thing. Sometimes what happens that you are working on the X-ray data, and you just want to point out the disease. So what you can do, you can just use this color map. And I'll just show you the outcome. You will understand what I want to say. But the thing is that, again, we'll have to read this image. It has done. Now, when I'm just reading it, you see? So even in this format also, although here you're not able to make the differences, but whenever you'll have the X-ray data, then obviously, for example, you're working to classify whether it's a pneumonia or not. In that case, this color map is really very helpful. Okay. All right. So we will just stop here. You can try with yourself. And on Thursday, we are going to see how a model will be applied. Yeah. How a model will be applied on it. Because a lot of things we have discussed today. Just work on it. Try this. And if you have any problem, we can discuss on Thursday. Otherwise, we are going to apply 1 or 2 pre-trained model on this data, and just to see how the classification is going on. Okay, everyone?
Sir, can you please share that decision tree file? I think it's, you still have not shared it. The decision tree file, Python file for classification.
Ji Khushbu, we'll share it today. I think decision tree, some other also has told me. Okay, I'll just do it right now. Don't worry. Okay, Khushbu?
Okay, thank you.
So let's stop here, everyone. Let's meet on Thursday at the same time, and we'll work on the modeling part of this images. And I hope now you have clarified the picture that how we can read your own images. Because so far, we had worked on the inbuilt images of the Keras dataset, but right now, we had read our own images. So today, I'll just share you the link of the drive from where you can download the Apple data, Apple images, and you can try by yourself also. If you feel if you face any error, we can discuss. Okay. So thank you, everyone. Thank you so much. Bye-bye. Take care. Good night.